Hello, hello. Welcome back to Print Talk. I'm Neil, and with me today is Kenneth. How are you today, Kenneth?
I'm doing great, Neil. Thanks for having me. Excited to talk about Nylon today. Me too.
Our listeners are really intrigued by this material.
Yeah, it's a fascinating one.
For sure. A little more, so we say demanding than some of the others.
Definitely. But that's what makes it so interesting. It's got real staying power in the 3D printing world, you know?
Yeah, for sure. So in this deep dive, think of it as a crash course in all things nylon for FDM 3D printing. We're going to go beyond the basics. We're going to really get into, what makes this material so special, the challenges it brings to the table,
right,
and how you can overcome them to create some seriously impressive prints.
Exactly.
So, Kenneth, you've been working with Nylon for a while now. What is it about this material that really sets it apart from the rest?
Well, I think it's versatility. It's not just some fad. It's got real-world applications. I mean, did you know that it's used in everything from surgical implants to car parts?
No kidding.
Yeah. And, its strength, flexibility, its resistance to heat and chemicals, it's incredible.
When you think about it, imagine printing a replacement part for your lawnmower. That's just as durable as the original.
Right.
Or even a custom tool for your workshop that can handle, the heat and the stress of a demanding project.
Yeah, it's really exciting.
It is exciting. But, let's be real. It's not as simple as, just hitting print and watching the magic happen.
No.
There are definitely some quirks to working with nylon. What would you say is the biggest hurdle, Kenneth?
I would say moisture is probably the biggest one.
Oh, the moisture monster, yeah.
Nylon is like a sponge. It absorbs moisture from the air, and that can really mess with your prints.
Okay, so how do we keep this moisture monster at bay? And I've heard a lot about the importance of proper storage. What's the deal with that?
Well, it all comes down to creating a barrier against humidity. Airtight containers, especially those that are designed for filament, are your best bet for everyday storage anyway. And then, those little desiccant packets you find in shoe boxes, but are lifesavers too.
Oh, yeah.
Toss a couple in with your filament to absorb any, stray moisture. And if you're thinking long-term, vacuum-sealed bags are the way to go.
Okay, so you're saying that those vacuum-sealed bags will actually, keep the nylon pristine until you're ready to print?
Pretty much. Okay.
Okay, great. Now, let's say, you didn't get the memo about storage, and now you suspect your filament has gotten a bit soggy. What are some of the telltale signs that we should be looking out for?
Listen closely when you start printing.
Okay.
Popping sounds during extrusion.
Okay.
Weak layer bonding, or a fuzzy surface finish.
Got it.
Those are all telltale signs that your filament needs a good drying.
All right, so what's the fix? How do we rescue our, moisture-laden filament?
A filament dryer is the gold standard, really.
Oh, yeah?
It gently heats the filament, driving out that moisture without damaging it. It's an investment for sure, but it's a game changer if you're serious about printing with nylon.
Okay, now, what if a filament dryer isn't in the budget just yet? Are there any DIY workarounds that you could recommend?
Well, some folks use their household oven, but I have to stress, that is a risky move. You have to be incredibly careful with the temperature. Too high, and you'll end up with a warped mess.
Yeah.
If you don't try it, set your oven to the lowest setting, like around 50 to 60 degrees Celsius, and keep a really close eye on the filament.
All right, so low and slow and watch it like a hawk. Got it. So we've got our nylon prepped and ready to roll. Now let's talk about the machine itself. Can any 3D printer handle nylon? Or are there specific features we need to look for?
Well, nylon is definitely more demanding than materials like PLA. Remember those impressive properties we talked about?
Yeah.
Well, they come with a price. Your printer needs to be able to handle the heat and the potential for work on them. Okay,
so walk us through the essentials. What are the must-have features for a nylon-ready printer?
An all-metal hot end is non-negotiable.
All right.
Standard PTFE line hot ends just can't handle the high temperatures required for nylon, which is typically printed between 250 and 280 degrees Celsius.
Wow.
So you need an all-metal design to withstand that kind of heat.
Got it. So all-metal hot end to handle the heat. What else should we be looking for?
Next up, a heated bed.
Okay.
There's a sauna for your prints.
Okay.
It's not just about keeping that first layer stuck down. It helps prevent warping.
Right.
which is a big issue with nylon because it tends to shrink as it cools.
So we're cranking that heated bed up to, what, 90 degrees Celsius?
Aim for 70 to 90 for standard nylon filaments.
Okay.
But you might need to go even higher for, specialty ones.
Right.
And while it's not strictly necessary, an enclosed print environment can make a world of difference.
Cuff.
That helps maintain a stable temperature, minimizing those cooling-induced stresses that can lead to warping.
So an all-metal hotend, a heated bed, and ideally an enclosure. What if my current printer doesn't tick all those boxes?
Well, if you're serious about exploring the world of nylon, you might want to consider an upgrade. There are some fantastic printers out there that are designed specifically for high-temperature materials.
Right.
Do your research. Read reviews.
What?
Find one that fits your needs and your budget.
Solid advice. So let's assume we've got the right printer, our filament is perfectly dry, and we're ready to dive into the, exciting world of print settings. Is it as easy as hitting print, or do we need to tweak things for nylon?
Nylon is definitely less forgiving than PLA when it comes to print settings.
Okay.
You can't just slap on a standard profile and expect perfect results.
All right, let's break it down. What are the key settings we need to pay attention to, and why?
Temperature is always crucial, but it's even more so with nylon. Start with the manufacturer's recommended range, usually around 250 to 280 degrees for the nozzle and 70 to 90 for the bed.
Okay.
But don't be afraid to experiment.
Yeah.
If you've seen poor layer bonding, try bumping up the nozzle temperature. Stringing issues, lower the temperature a bit.
Right.
It's all about finding that sweet spot.
So we're playing Goldilocks with the temperature. Not too hot, not too cold, but just right. What about print speed? Can we crank it up for faster results, or should we be taking things slow and steady?
Slow and steady wins the race of nylon.
Good.
Think of it like this. Rushing the process with high print speeds can lead to under-extrusion and weaker parts. You want those layers to bond properly, so stick to the speed at around 30 to 50 millimeters per second.
Okay.
Trust me, patience pays off with nylon.
Got it. Slow and steady for strong, well-bonded layers. What about layer height? How does that factor into the equation?
Well, layer height affects both the level of detail and the overall strength of your prints.
Yeah.
For most nylon projects, a good starting point is 0.1 to 0.2 millimeters, You can go thinner for intricate details, but keep in mind that thicker layers will print faster.
Yeah.
But, potentially at the cost of some strength.
It's the balancing act, as always. Are there any other settings we should be tweaking in our slicer?
Absolutely. Retraction settings are key for combating stringing. Those little wisps of plastic.
Yeah.
Can be a real nuisance, especially with nylon, which has a high flow rate.
Okay.
Experiment with your retraction distance and speed. Start with a distance of 2 to 4 millimeters and go from there.
Retraction.
Yeah.
Check. Now, what about cooling? Do we want to blast our nylon prints with the fan, or is that a recipe for disaster?
Cooling is a bit of a balancing act with nylon.
Okay.
Too much cooling can cause warping.
Right.
For the first few layers, keep the fan off entirely to promote good bed adhesion.
Okay.
As the print progresses, you can gradually introduce some cooling, but keep it gentle, maybe 10 to 20% fan speed.
So we're treating our nylon prints like delicate flowers, gentle cooling to prevent those warping tantrums.
Exactly.
All right. Anything else we need to fine-tune before we hit that print button?
One more critical factor. Bed adhesion.
Oh.
It's the foundation of any successful print, but it's especially crucial with nylon because of its tendency to warp.
Right. We've talked about a heated bed and an enclosure, but are there any other tricks for ensuring our nylon prints stick like glue and don't go rogue mid-print?
Well, choosing the right build surface and adhesion aids can make a world of difference.
Okay. Let's talk about build surfaces first. What are some of the best options for nylon printing?
Garolite sheets are a favorite among nylon enthusiasts.
Okay.
They have a textured surface that provides excellent grip and can withstand those high printing temperatures.
What if I'm working with a standard glass bed?
A thin layer of PVA glue stick can work wonders for bed adhesion.
Oh, yeah?
It creates a nice sticky surface that helps keep the nylon in place.
And if I'm feeling adventurous and want to explore other options?
You could try BuildTack sheets or nylon-specific adhesive sheets.
Okay.
They're both designed to handle the challenges of printing with nylon and can be a great alternative to glue sticks.
So many choices. It sounds like there's a perfect build surface out there for every printer and every preference.
Yeah, definitely.
What about adhesion aids? Are there any extra steps we can take to boost that stickiness factor?
Sometimes a little bit of prep work goes a long way.
Okay.
Lightly sanding the build surface with fine grit sandpaper
Okay.
can create a slightly rougher texture, which gives the nylon more to grip onto.
Right.
So whether using Garolite or glass, a quick sanding can help improve adhesion.
Great tip. So we've covered the importance of a nylon-ready printer, proper filament storage, and those crucial print settings. What else do we need to know before embarking on this nylon printing adventure?
Well, there's more to nylon than meets the eye.
Ooh.
We talk about pure nylon,
Right.
but there's a whole universe of nylon blends out there, each with its own unique set of properties and applications.
Oh, this is where it gets interesting. Tell us more about these mysterious nylon blends. What are they, and why should we be excited about them?
Think of nylon blends as enhanced versions of pure nylon, tailored for specific needs.
Okay.
They take the already impressive qualities of nylon and amplify them by adding other materials into the mix.
Okay, give us some examples. What kind of blends are out there, and what superpowers do they possess?
One of the most popular is carbon fiber reinforced nylon.
Oh, wow.
It's incredibly stiff, strong, and resistant to warping,
Really?
making it perfect for structural parts like frames and brackets.
Wow.
Imagine printing drone components that are as tough as injection molded parts.
Wow.
That's what kind of durability we're talking about with this blend.
So it's like having the strength of metal, but with the printability of plastic.
Exactly.
That's pretty cool. What other blends are making waves in the 3D printing world?
Another game changer is glass fiber reinforced nylon.
Okay.
It gives you increased stiffness and reduced warping, similar to carbon fiber,
Okay.
but it retains more of the nylon's natural flexibility.
So it's kind of like the best of both worlds.
Yeah. It's an excellent choice for functional prototypes or moving mechanisms that need to be both strong and have a bit of give.
Now, for our listeners who are all about eco-conscious choices, are there any sustainable nylon options out there?
Absolutely. Recycled nylon filaments are becoming more and more popular.
Well, cool.
They're made from reclaimed materials like fishing nets,
Really?
and they offer a fantastic way to reduce your environmental impact without compromising on performance.
That's fantastic. So we've got pure nylon, carbon fiber blends, glass fiber blends, and even recycled options. It sounds like there's a nylon filament out there for every project and every priority.
That's the beauty of it. With so many options, you can fine-tune your material choice to perfectly match the demands of your project.
Now, even with the best preparation and settings, we all know that 3D printing can throw us a curveball now and then.
Yeah.
What are some common challenges we might face when printing with nylon, and how can we troubleshoot them like pros?
Even seasoned printing veterans run into hiccups with nylon. One of the most common issues is warping, even with all the preventative measures we've discussed.
Right, we've talked about the importance of a heated bed and enclosure and the right adhesion aids. But what if warping still rears its ugly head? What are our next steps?
First, double-check your bed temperature.
Okay.
It might need a little nudge upward, especially for larger or more intricate prints.
Okay.
And make sure your build surface is spotless. Any dust or debris can interfere with adhesion.
So temperature and a pristine build surface.
Yeah.
What about those pesky strings and oozing that can sometimes plague our prints?
Yes, the dreaded stringing and oozing. First and foremost, make sure your filament is bone dry.
Okay.
Moisture can make these issues much worse. Then take a look at your retraction settings.
Oh.
You might need to bump up your retraction distance or speed a bit.
Right.
And if you're seeing excessive oozing, try lowering the nozzle temperature slightly.
Dry filament, retraction tweaks, and a temperature adjustment. Anything else we should keep in mind when battling stringing and oozing?
Sometimes, slowing down your print speed can help.
Right.
Rushing the process can exacerbate these issues, so patience is key.
Makes sense. Now let's talk about another potential heartbreak.
Right.
Layer delamination.
Right.
What causes it and how do we fix it?
Layer delamination is when the layers of your print just don't want to bond properly,
Right.
resulting in a weak, easily separated part.
Yeah.
The usual suspects are insufficient nozzle temperature or printing too fast.
Okay.
Try bumping up your nozzle temperature by 5 to 10 degrees and slowing down your print speed.
So it's all about finding that sweet spot with temperature and speed.
Yeah.
Now let's shift gears and talk about post-processing.
Okay.
Can we enhance our nylon prints once they're off the printer, or is what you see what you get?
Post-processing can definitely take your nylon prints to the next level,
Okay.
aesthetically and functionally.
What kind of techniques are we talking about here? Fill us in.
Sanding is a great way to smooth out rough edges or layer lines.
Okay.
Especially if you're going for a polished look, start with a coarse grit sandpaper for initial shaping.
Okay.
Then gradually move to finer grits for a super smooth finish.
Sanding. Check. What else can we do to spruce up our nylon creations?
Dyeing is another fantastic option.
Okay.
Nylon's absorbent nature makes it easy to color using fabric dyes, specifically designed for polyamides.
Oh, cool.
You can achieve vibrant, even colors,
Say,
adding a whole new dimension to your prints. Imagine customizing your functional parts with color coding,
yeah.
or creating eye-catching designs on decorative pieces.
Dyeing. Another way to unleash our creativity.
Yeah.
Any other post-processing tricks up your sleeve?
For parts that need to be extra tough, annealing can be a game changer.
Oh.
It involves heating the printed part in an oven to a specific temperature, which helps relieve internal stresses
Okay.
and results in increased strength and improved dimensional stability.
So if I'm printing something that needs to be, like, seriously durable, annealing is a must-do.
It's definitely worth considering. Just be sure to research the proper annealing temperatures and times for your specific nylon blend. Too much heat, and you could end up with a warped or brittle part.
Great advice. Now I'm curious, Kenneth. What are some of the more unusual or unexpected applications you've come across for nylon 3D printing?
One that always comes to mind is the use of nylon in 3D printed fabrics. Wait.
3D printed fabrics, you mean like clothes and textiles?
Exactly.
Wow.
There are some incredible techniques being developed that involve 3D printing, intricate, flexible structures using nylon.
Really?
Yeah. These structures can be incorporated into fabrics to create unique textures, patterns, or even functional elements.
Did you have clothing with like built-in ventilation or padding, all thanks to 3D printed nylon?
Absolutely.
That's mind-blowing.
It is, and it just goes to show that nylon is constantly pushing the boundaries of what's possible with 3D printing.
Speaking of pushing boundaries, we have some listener questions coming in. Let's see what Lisherness. It looks like Lisherness is curious about printing flexible parts with nylon.
That's a great question, and it reminds me of something we touched on earlier, nylon's inherent flexibility. But can we really achieve like that rubbery, bendy quality with 3D printed nylon?
That's where I'm wondering. We talked about, how great it is for hinges and moving parts, but can it really compete with those super flexible materials we see in like phone cases and gaskets?
To a certain extent, yes. Pure nylon does have some flexibility, but it's not quite as rubbery as, some other materials. If you're aiming for that, like, truly bendy quality, you might want to explore some of those nylon blends we discussed earlier.
Which ones come to mind for flexible parts?
There's a type of nylon, it's often called flexible nylon, or TPE nylon. Okay. It's a blend of nylon and a thermoplastic elastomer.
Okay, or
TPE, which gives it that extra rubbery elastic quality.
so it's like a hybrid that combines the strength of nylon with the stretchiness of a TPE. That sounds perfect for parts that need to, bend and flex without breaking.
Exactly. It's a fantastic option for things like phone cases, wearable pec straps,
Right?
flexible gaskets, or even shock-absorbing components.
So the next time I'm admiring the flexibility of my smartwatch strap, it might just be thanks to flexible nylon.
It could be.
Going back to a listener's question,
Yeah,
do you have any tips for achieving flexibility with nylon?
absolutely. If they're looking for maximum flexibility, I definitely recommend checking out those flexible nylon blends.
Okay.
But even with pure nylon, you can influence the flexibility of your prints through your settings.
Hold on. Are you saying I can actually tweak things to get more bend in my nylon prints?
Yeah,
Even if I'm not using a special blend?
exactly. One key factor is infill.
Okay. Lower.
Infill percentages will result in a more flexible part.
Okay.
Think of it like this. More infill means more internal structure, which makes the part stiffer.
Right.
Less infill creates more air pockets within the part, allowing for more flex.
So if I'm printing like a hinge or a flexible component, I'd want to dial down the infill. What kind of percentages are we talking about here?
It really depends on the part and how much flex you want.
Yeah.
You can experiment with infill percentages as low as 10 to 20%.
Okay. Infill is one lever we can pull. Any other settings that can impact flexibility?
Layer height plays a role too.
Okay. There.
Layers will generally result in a more flexible part because there are more bend points within the print.
That makes sense. It's like having a chain with more lengths. It's more flexible than a chain with fewer larger lengths.
That's a great analogy.
So let's say I've dialed in my infill and layer height for maximum flexibility, but my nylon print still feels a bit too stiff. Are there any post-processing techniques that can help?
believe it or not, annealing, which we talked about earlier,
Okay.
actually improve flexibility in some cases.
Oh,
By relieving those internal stresses within the part, annealing can make it less brittle and more likely to bend without breaking.
wow, I didn't realize that annealing could enhance both strength and flexibility. It seems like there's always more to learn about this material.
There is. Nylon is full of surprises.
Speaking of surprises, what are some of the more unusual or unexpected applications you've come across for nylon 3D printing?
One that always fascinates me is the use of nylon in 3D printed medical devices.
Really?
Tell me more about that. Because nylon is biocompatible. It can be used to create custom implants, prosthetics, and even surgical guides that are tailored to a patient's specific anatomy. It's revolutionizing the way we approach healthcare.
That's incredible. To think that we can now print like customized medical solutions on demand is mind-blowing. It really highlights, the transformative potential of 3D printing.
It does, and nylon is, at the forefront of this revolution.
Now, for our listeners who are, new to nylon, what advice would you give them? Where should they start?
My advice would be, don't be intimidated.
Yeah.
Nylon might seem complex.
Right?
But with a little patience and experimentation, it can really elevate your 3D printing game. So start with a simple project, maybe a small functional part, or a prototype, and gradually work your way up to more challenging prints as you gain confidence.
That's good advice. And remember, the 3D Brain community is a fantastic resource. There are countless online forums, tutorials, and communities where you can connect with fellow enthusiasts, share tips, and troubleshoot problems.
Exactly. The beauty of 3D printing is that it's a constantly evolving field.
Right.
And there's always something new to learn and explore.
Sounds like we have another question from Listeners. Let's see what they're curious about now. It looks like Listeners is wondering about the differences between nylon filaments from different manufacturers.
Yeah, they're asking if there's a noticeable difference between brands or if they're all essentially the same.
That's a great question, Listeners. I think a lot of people wonder about that. When you're browsing all those nylon filament options online, it can definitely feel overwhelming.
It's a valid concern. While all nylon filaments share some, fundamental characteristics, there can be significant variations between brands when it comes to quality, consistency, and even specific properties.
Let's dive into that a bit. What are some key factors that might differ between nylon filaments from different manufacturers?
One crucial factor is the purity of the nylon.
Okay.
Some manufacturers use higher grade nylon resins, which can lead to filaments that are stronger, more durable, and less prone to issues like moisture absorption.
Okay.
Think of it like this. You wouldn't expect a cake made with, bargain bin flour to be as delicious as one made with premium, finely milled flour.
Right.
The quality of the ingredients matters.
This makes sense. What else should we be paying attention to when comparing nylon filaments?
Consistency of filament diameter is another big one.
Okay.
Variations in diameter can cause inconsistent extrusion, leading to those annoying blobs, gaps, or even layer shifts in your prints. You want a filament that's like a perfectly smooth, uniform strand of spaghetti, not one that's lumpy and uneven.
Definitely. I've got my fair share of filament nightmares. What about those nylon blends we talked about earlier? Are there differences between brands in terms of, blend quality or composition?
Absolutely. The type, quality, and concentration of additives used in nylon blends do vary significantly. For instance, one brand's carbon fiber reinforced nylon might have a higher percentage of carbon fiber than another, leading to a stiffer, stronger material.
So it's not enough to just look for carbon fiber nylon. We need to dig a little deeper and see what percentage of carbon fiber is actually present.
Exactly. And don't hesitate to reach out to manufacturers directly if you have questions about their filaments. They're usually happy to provide more detailed information.
Great advice. Now, for our listeners who might be feeling a little lost in the world of nylon filament options, are there any brands or manufacturers you'd recommend as a starting point?
Several reputable brands are known for their high-quality nylon filaments. A few that come to mind are Tallman, Matter Hackers, and Polymaker.
Those were all names I've heard good things about. So, to answer your question, Listeners, brand absolutely matters when it comes to nylon filaments. It's not just about the name on the label. It's about the quality and consistency of the material itself.
Well said. It's always wise to do your research, read reviews, and maybe even try out a few different brands to find the ones that work best for your printer and your specific projects. What works for one person might not work for another, so a little experimentation never hurts.
As we wrap up our deep dive into the world of nylon, I want to leave our listeners with this thought. Nylon really embodies the spirit of 3D printing. It's about pushing boundaries, exploring new possibilities, and creating things that were once unimaginable.
I couldn't agree more. It's a material that challenges us to think beyond the ordinary and embrace the power of innovation.
So whether you're a seasoned 3D printing pro or just starting out, don't be afraid to give nylon a try. With a little patience, some experimentation, and the knowledge you've gained today, you might just unlock a whole new world of creative potential.
Exactly. Can't wait to see what you create. Happy printing, everyone!